Before, it was dark. Then it came the light. It was the Big Bang and the beginning of everything. During these first seconds of the universe, everything was very, very hot and dense. And this primordial state of matter is called quark-gluon plasma. We are made of matter. Matter is made of molecules. Molecules are made of atoms. In the atoms we find the nucleus. In the nucleus we find the protons and the neutrons. And in the protons and the neutrons we find the quarks, the indivisible and fundamental particles. In the first second of the universe, their matter was melted like in a soup of quarks. I studied this soup. Why? Because we want to understand how this primordial matter go to the matter as we know today. We want to understand why everything sticks together and how we can reproduce this matter for the first second of the universe. For that, particle physicists built particle colliders. You can see one in the picture. This is the particle collider called RIC. It's half an hour from here in Brookhaven National Lab. Here, there are two rings and the particles go around and then they collide. And in every collision, we had like a small Big Bang. And how we can study this collision? For that, we had our digital cameras. This is my digital camera, it's the Phoenix detector. And that is my picture, the picture of the particles that are produced in the collision and detected by our detectors. Studying these particles, we can study the properties of the matter that is created. One important property of this matter created is the temperature. It's the thing that I do, I measure the temperature. But how exactly I measure the temperature? Well, let's go to an example. Here, we had a zebra to measure the temperature, but it's a wild animal, we cannot use a thermometer. So we can measure the infrared radiation produced by the zebra. I do the same because the collision is very, very hot, I cannot use a thermometer. So I measure the radiation produced in the collision. I measure the photons. We can understand photons like particles of light, but very, very energetic. And how hot is this collision? It's 80 times the temperature of the core of the sun. This that I told you today is just a very small piece of the understanding of the origin of everything. From my side, I will continue cooking my primordial soup.